Okay, hi guys. I've gotten a few questions about electron dot diagrams. So I'm going to try my first YouTube video where you guys can see my hands doing some of the work. So hello. I have on my periodic table. I'm hoping that you do too. I am going to upload it to the files so that you can hopefully see the periodic table right now as I'm showing you. So some of you are wondering about on this assignment, this part right here where you don't know how to draw the electron dots for aluminum or chlorine. I won't do the ones from the assignment, but I will show you a few examples from the periodic table so that you can see how I would do that. So remember when we were learning electron configuration, we talked about how on the periodic table, this group all has one valence electron. This group has two. This group has three. This has four. This group 5 has 5. Group 6 has 6. Group 7 has 7. And group 8 has 8, except for helium. We know he is a 1s2, so he only has 2 valence electrons. He's a little different. Everybody else in the noble gases has 8 in its outside shell, full valence shell. And so I've asked you to draw on the assignment aluminum, the electron dot diagram for aluminum. I'm going to show you how to do silicon right beside it. So silicon is in family 1, 2, 3, 4, group 4. And so if I was going to draw the electron dot for silicon, I would write the symbol for the element, and then I would know that it was in group 4. So I would have 4 valence electrons. I would put one on each side like this, remembering that this is just a representation. This is just how we easily and simplify a model. So knowing that the electrons are all negative, I would have them evenly spread out. They would never go next to each other if they didn't have to, remembering that they would be repulsion and they would all be negatively charged. And so I would put an electron configuration like that around silicon. How would I do it for something like bromine? Well, let's look at bromine. Bromine is in the family 7 or group 7. And so bromine there's the symbol. I would draw 1, 2, 3, 4 dots around, evenly spread out. And then I would fill in 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So that would be how I would draw bromine. It doesn't matter what side. This is also correct. If I had the single electron on that side, that doesn't matter. Remembering this is just a simplified representation of easily to help us learn bonding kind of a model. This isn't a specific placement. Remembering that our electrons are in these clouds of probability in real life. And so let's look at this bromine. What if I had a sodium that was nearby? When we look at sodium, we look and we know they're in the first family. So we know they have 1 valence electron. So if it was near, sorry, forgot the R. If it was near this bromine, it would look like this. What do we think might happen if these two elements were in proximity to one another? We know that this sodium would love to see this electron go, and bromine would love to accept the 8th electron to have a full outer shell. If sodium got rid of that one, it would also have a full outside shell. Both would be very content and like noble gas. So that would easily happen. This electron would go here, making bromine negative. It would make the sodium positive. We now have a positively charged particle and a negatively charged particle, which would give us NaBr, sodium bromide. We'll learn a bit more about this in the next section that we do, and we'll learn how to name sodium bromide. I think you did that a little bit in Science 10, but I'll review it and take you a little deeper, naming acids and so on here as we go online. But this is what I wanted to show you today. Please keep giving me your questions. I can't read your minds. It certainly can't read your minds from here. So I need you to zip me email or send me something to say, I don't really understand this. And then I'll do videos like this to help everybody understand. So hopefully everybody's doing well, staying socially isolated, feeling healthy, taking some walks, taking care of each other and your families and yourselves. Yeah. That's it, guys. Stay well. Have a good Easter weekend. Stay self-isolating, and I'll do another video whenever you need me to, or whenever I think it's something that's a little harder to understand. Okay, bye for now. Bye.